Cool. Yeah, great to have everyone here. I'm really looking forward to this talk. Yeah, so this will be about Kubernetes bringing QA and DevOps closer together, so a practical approach to DevTestOps. My name is Niels Balke-Tüxen, and I'm the lead QA engineer at Humanitech.
And I'm Michał, DevOps engineer at BNY Mellon.
Yeah, before we start, I have a small questionnaire for everyone. So we know basically what your expertise is in the topic, and maybe we can adjust slightly. And you will also get an idea of what topics we'll touch today. So let's see. So this is a link to a Google form. And I hope you can see this as well. So basically what I would like to know is what your expertise is in the topics we're going to talk about today. So for example, I'll fill this out myself as well. So I'm working in quality assurance and software testing for more than 20 years. I'm putting myself as a 5 there. DevOps is something I really like doing, but I'm not a DevOps engineer, and I'm only exposed partially to what's been happening there. So I'm putting myself as a 2. Robotframework, I'm now working with Robotframework since roughly 2 years. I'm putting myself as a 4. There's still definitely things to learn there. And with Kubernetes, I'm also working now since 2 years with Kubernetes. So I'm also putting myself as a 4 there. I think I know most of the core objects, but there's so much things, such a big ecosystem to learn. So I will submit this. What about you, Mija?
Right. So from my side, I started as a tester. So as for quality assurance, I would put myself as 3. Then last couple of years, I'm working as a DevOps engineer. So I would say it's 4. And my expertise with Robotframework, it's also 3, but I was working in Nokia for a couple of years, and this is where the Robotframework was born. So I had to learn it somehow. And for Kubernetes, I'm very excited about it, but not too many years working with Kubernetes. I would say something between 3 and 4.
Yeah, that's pretty good. Yeah, let's see what you guys were saying. So what's quite interesting, so there's also more people than who feel home in QA than who don't, but there's also some people who are not necessarily a tester or QA engineer. That's interesting to see. And then DevOps, there's a lot of people with some knowledge, also a bit more solid knowledge, which is also nice to see. And then Robotframework, there's only a few people knowing it, and then a lot of people who don't know it. So I'll try to explain this a little bit more to you, what this is about. And then Kubernetes, also a lot of people who don't know Kubernetes very well, and some who have some knowledge of it. So we'll try to go into it also a little bit deeper. Cool, great.
Yep.
Let's switch to the slides. Wait, I need my notes. All right. Cool. So yeah, so today we'll talk about Kubernetes, the concept of DevTestOps, and the testing framework called Robotframework, as well as the open source project called KubeLibrary. But first of all, let's talk about some of the challenges we see when working in QA and DevOps. So for example, one of my most common challenges is when I look at the test report and the test has failed, I need to be able to do a root cause analysis as quickly as possible. So let's say you have a UI test which failed because it couldn't reach the website. So you have to ask yourself, is the front end correctly deployed? Is the service available? Is the app correctly configured? A root cause analysis in those cases, or short RCA, can take some time and resources. Some of the issues can be infrastructure related, and I often need the help of a developer or of a DevOps engineer. So over to you, Mija.
Right. So, as Niels mentioned, some of the RCAs can lead to the infrastructure problems, but infrastructure itself is such a broad topic. If we try to name at least a couple of main parts from DevOps world, we could start with resources, right? So those are usually the computing resources, networking, or storage. All of them can have some different stacks and tools to handle them. And some specific automation, like for example, Terraform. Then if we have computing resources, we could think of deployment, and either those are packages or we are spawning containers. But we also need to keep configuration and secrets in a separate place according to the best practices. Then at some point we would like to make upgrades of the whole system, right? So if it's a monolith system, we usually have some custom processes for that. If those are containers, then some things are a bit easier. Then we are thinking about some failover scenarios. So we want to make our system more robust and like handling some disasters. And again, we can have some duplicate system that kicks in whenever there is some disaster. We can have some duplicate services, yeah, and so on. Then we would like to monitor the system. So it would be nice to have some overview of what's going on. And last part is the access control, right? So we are just limiting the access, limiting the parts of the system that are available to the different groups of users, right? And now imagine that the whole thing is already pretty complex, and imagine that some of it fails, right? You need to go to each of those parts, use different vendors, different approaches to dig into the actual problem, right? I was once working in a team that was responsible for corporate private cloud, and what the way they was addressing the complexity of the infrastructure is by running tests. But there was no sense to run like hundreds of tests and checking all the APIs. What they did is to simply run a couple of very easy, very simple end-to-end tests, checking if, for example, VM can be created, if storage is available, and things like this. Well, getting into the problem whenever one of those tests failed is another story, but you can imagine how complex the whole thing was. And notice that I didn't place any of it in any specific scenario because I think it applies to most of the systems and applications. And around 7 years ago, Kubernetes was born with the aim to abstract all those things in a declarative API, right? So it not resolved all the problems, but at least it named it somehow and described as some objects that can be handled and kept in the system. So as for resources, we have Kubernetes nodes, which represent computing resources. We have some setup for networking, like services and ingresses and endpoints. For deployments, of course, we are working on containers. We define something called pod, which is like the minimal functionality represented by a couple of services that needs to work together to provide this functionality. Then we have config maps for configuration and secrets for secrets. Obviously, it's not any magic that it somehow is in Kubernetes. We need to provide it, inject all those configuration and secrets into the system. But at least we are naming all of those things in some common generic way, right? We are creating the abstract layer that can be handled in different levels, right? Then there are upgrades. For upgrades, we have rolling upgrades. We have some solutions for persistency and stateful workloads. For failovers, we define what the crash for the service means, right? We can define what Kubernetes should check to say that the service has some failure, right, or it's not responding. We have replicas, so the pods are replicated. We have a couple of copies of the service. We're just waiting to respond whenever one of it is not available. And for monitoring, Kubernetes itself keeps statuses and events for different objects. But again, if we have the common ground, common platform that is shared between teams or even between companies, then it promotes build of the ecosystem and some generic solutions that can be like common solutions that can be used by everybody, right? And for access control, we have airbag. So we can very granularly assign which objects can be accessed by which roles and which people. And it's not about containers only, as Darren Shepard tweet I really liked. So we already have a lot of systems that is handling containers only. But the real benefit in Kubernetes is the API, right? Because it names, it abstracts all those things, and also you can create your custom resources if it's missing anything you'd like to represent. And also you can create your own logic to handle it in form of operators. You can inject sidecars which are handling authorization, making all your workloads not even aware that they are secured by some other containers or services, right? But yeah, all of this is circulating around DevOps, but at least we think that it's more deeper concept, and Niels will explain it in a second.
Thanks. Yeah. So yeah, Kubernetes seems to be clearly an infrastructure or DevOps topic. So the question is, why would I care about it as a tester? Well, let's talk about DevOps in general and the role of testing in it. I'm quoting here one of the many definitions you can find for DevOps. So DevOps is a discipline rooted in collaboration and communication, made possible by removing perceived barriers between teams and building trust in a culture of learning and continuous improvement, and drawing from proven technical and management practices that work toward a common goal of shortening software delivery cycles and improving the stability of deployments. Well, while it is claiming continuous improvement and stability of deployments, it does not explicitly talk about testing in there. I truly believe if you want to adopt DevOps principles, you need to adopt continuous testing. The goal of continuous testing is to test early and to test often. In DevOps, most of the manual operations during the software development lifecycle are automated, which result in faster delivery. As DevOps does not primarily focus on continuous testing, there can be possibilities of defect leakage, missing scenarios, and business requirements in the product. So to ensure faster delivery with a better quality, the concept of DevTestOps was introduced, which is emphasizing on continuous testing. And since we are talking a lot about testing now, I think it's time to introduce you to the testing framework of our choice. So why are we using the Robot framework? So especially if you haven't heard about it, this might be interesting for you. There are many testing frameworks out there, and I would like to highlight why we choose the Robot framework. The Robot framework is an open source testing framework maintained by a big global community. While using the Robot framework for UI testing or for API testing, where it's most popular, it actually provides a much bigger ecosystem of integrations for a vast range of technologies. For example, you can do like Windows UI testing or SAP GUI UI testing with it, with libraries, or there's a library specifically for testing RabbitMQ message ingestion, or for Kafka, for example, or there's a library specifically for database testing, and so on. Overall, if you look into the Python package index, you find more than 400 integrations available for Robot framework as of today. The reason for this is that the Robot framework is very easy to extend, and it provides tooling to auto-generate documentation for written extensions. So this makes any individual contribution to the ecosystem accessible by anyone else. And we will also show this in a bit to you, how this looks for the QubeLibrary. So what's also worth mentioning is if you see the robot framework for the first time, it might look a little bit weird. It goes a keyword-driven approach. So meaning that you any test you write in robot framework can be made readable in plain English. So a little bit like behavior-driven development, which is also supported by robot framework. This makes tests and test reports accessible to colleagues without even having a coding background, right? So Kubernetes gives us the possibility to control and check our infrastructure and application, while the robot framework gives us clearly structured and readable tests. So I think now it's time to tell you why we started to work on this KubeLibrary project.
Right, so the motivation behind KubeLibrary was simply to ease Ansible and Terraform development of Kubernetes platform I was working on at that time. Something that could be used in CI, for example, trying to mimic test-driven development, right? So first writing the test and then just seeing how the end system after the changes behaves and how it looks like, what it has. Originally it was just handling a couple of clusters and focusing on very simple tests. But I thought with some extra polishing, it could be useful for other people. And this was the time where Niels came in saying that he was thinking about something similar. And yeah, we joined forces and end up here talking about KubeLibrary to other people. Niels, could you tell a little bit more how it helped you with your work?
Yeah, yes, of course. So at Humanitech, so that's where I'm working, our product is an internal developer platform. So think about a platform as a service like Heroku, but with the possibility to connect your own tech and tools like Kubernetes clusters. For example, when I test deploying with Humanitech to a Kubernetes cluster, I need to be able to verify if the application is successfully running inside the cluster. Before the KubeLibrary, I only was able to check if my application was available. And if it was not available, I had to analyze the issue manually. Now with the KubeLibrary, my test automation can check directly inside the cluster if everything is available and ready to test. I even get the application container logs and show them inside my test report, which is helping a lot with the root cause analysis if there was any failure. So in the end, we figured out that the KubeLibrary can be also quite useful to others. And in order to bring DevTestOps to life, we decided to fuse the best out of two worlds. All right. I think now it's time for a demo, and I will hand over presentation rights to you, Mija. Just a second. Okay. Make host. Yes.
Okay, I have something. And I will start with this one. Okay, hope you can see my screen. So I think the best way to explain what is KubeLibrary is to go to its GitHub page. So KubeLibrary is just a thin wrapper around Python Kubernetes client, right? So we are just using some of its functions to access Kubernetes. Mostly those are the functions that are getting some objects, reading some statuses and things like this, something that we can use in our tests. Of course, we are not covering all the API because it's yeah, huge, right? If you like to see what we are really covering, you can go to the documentation. And here you will find a nice list of all the keywords with explanation, the arguments, and what it is returning. And for all of those keywords, we are creating examples. So actually, this is kind of definition of done for us for all the changes. Whenever there is a new keyword, we try to write some examples, and those examples are executed in our CI. So as a user, you get two things. First of all, you have examples and you know how to use it, and second of all, you are pretty sure that it's working with the latest version of our library. And this is exactly what I will show you now. Just a very simple steps you can do just after this presentation, something that you can make use of this library and see some results, see green tests, and yeah, say that you use it at least once. So I will focus on this one, so Grafana tests. As a first step, I will just spawn Grafana service on my Kubernetes cluster. And by the way, I'm using K3D, so it's just local cluster that is running on my laptop. And what I'm doing now is just adding the repository for Grafana, updating it, and it is already deployed on my system, on my Kubernetes. I can show you that it is being spawned. It will take like a minute or two. So meanwhile, I will copy another thing. So I guess you are seeing only my Firefox, right?
Yeah.
Okay, so I will not switch to terminal, but believe me, I'm just copying it for now and setting those settings in the terminal. And I do it simply to provide the parameters needed to run the tests for Grafana. So this only also to show that you can arrange your tests in a way that it can be generic, but by providing those parameters, you can focus the test on some specific applications. So as I said, we need some time to. So meanwhile, I will show you the examples. So in test cases, I will be running the system smoke test. So this one. And running tests only for Grafana. As you can see, the keywords can be, or test cases can be labeled. So we can nicely structure all the tests you want to run. And in this case, I'm using given when then pattern, right? So all my tests are quite readable, I hope. Even if you are not familiar with Robotframework with Kubernetes, I'm sure you are more or less getting what's going on here. So in the first test, I'm just checking first if the API is accessible, then checking in volume claims are existing, and if Grafana has exactly one volume claim. Then another one is that I'm checking if the volume claim has 1 gigabyte, and if service is exposed correctly, as you can see in the next test. And the last one would be that we are just checking if the application is exposed using load balancer on port 3000. So that's basically it. I will switch now to my terminal. Right, so you should see my terminal now.
No,
and
I think it's a wrong window. It's very small.
Okay, let me try again then. Okay,
yeah,
now
that looks better.
should be better. Yeah, okay. So you missed this the copy paste part, but yeah. So I just started Grafana here, and it was at that time it was just running. It was not ready yet. I copied those parameters, and I can now try getting the pods once again, and now you can see they are running. So I will do one last step, which is just run the actual test cases. So this will be this one. And since I'm using virtual environment here, I need to do it like this. So yeah, I will be running robot against Grafana labels or tags. but I will exclude the pre-release tags, which is the way how we handle new examples that are not yet supported by the latest release, right? So it will just run the Grafana test without the newest examples. And as a source, I'm passing test cases folder, right? So this should run all the tests. And as you can see, all of them are passing. You can run those tests as a developer when you are developing new application or changing your application, when you are developing new Helm chart, for example. The same test can be run by a testing team if they just checking if the production system is okay. It can be run by operations team if they are looking into some problems and try to limit the possibilities. And yeah, so normally you would do it by running kubectl, and this way you can just run very quick test to see if everything is as supposed to be. I will not go into details about the report because Niels prepared some more practical examples, so I will just pass it to him.
Cool. Thank you very much.
Just a second.
Let's see. Yeah, so I hope you have now a pretty good idea how the QubeLibrary is working. I want to give you an example. So I want to use a QubeLibrary here as a prerequisite of a UI test. So by adding checks, if your system under test is fully available and configured in the right way, you can make your tests less flaky. And if they fail due to an infrastructure or configuration problem, they will fail much sooner, saving you precious time. Also, root cause analysis in those cases should be much faster because it should tell you what's actually wrong under the hood and not only with your application UI. So I prepared a little test, and I hope you can see my my screen here. So again, Robotframework. I'm using here 3 libraries, two of them important for this test. So one is the KubeLibrary we are talking about, essentially being a wrapper around the Kubernetes Python client. And the other one is a browser library, which is a UI testing library, a bit more modern than Selenium, and it's based off the open source project from Microsoft called Playwright. So in this test, I'm also using Grafana because Grafana also comes with a nice dashboard UI. So imagine your application under test has a UI and you need to verify that you can log in, right? In this test, I will also do some things similar to the test we've seen before. So basically checking that Grafana is running, and Grafana has basically a couple of objects inside the Kubernetes cluster we can check. So we can check if the deployment is done. We can check if all replicas are running. We can check on the pods. We can check on the service, on the secrets, the service accounts. And I did forget in this test to check on the config maps actually, but yeah, something I can enhance. And then we'll basically obtain the URL from the service object, right? So if you install Grafana, you don't necessarily know the URL right away, right? So it will get an IP address, usually through your load balancer, and you will also need to know the port it's using. And then on top of that, if you install Grafana for the first time, it will create randomly generated access credentials. So you will have an account and a password, and both will be stored inside Kubernetes in the secrets object. So we will grab those. And then we'll run a quick UI test with those things and hopefully successfully log into the Grafana UI dashboard. So this is just the test structure, right? And how Robotframework works is that each of those tests are basically defined then in those keywords I was mentioning earlier. So what you see here, for example, is get service details and namespace. This is actually a keyword from the KubeLibrary, and we are passing on the name of the service we want to get, as well as the namespace it's running in. And then we basically get an object back, the service details, and then we need to navigate in this object to status, load balancer, the ingress, the first ingress object, and then the IP address. And this is where basically the application runs on. But I will show you this to you in a little bit more detail on the test report. So on secrets, it gets a bit more interesting because secrets are stored base 64 in code, so we can directly decode them and then use them and store them in a variable. And then finally, we will use all those information we obtained from the Kubernetes cluster to then log in with this short UI test. Yeah, written in the browser library. All right, let me quickly change to my bash. Okay. So we run this test. I'm also connected to a QA cluster. Mine is running in Google Cloud. It doesn't matter. It also is running Grafana, which we will see in a second. This is a UI test when the browser will come on. I will try to switch to it as quickly as possible, but I can't promise if this is working. Let's see. So you should now see the Grafana UI. So what you're also seeing is that the API test to Kubernetes went through quite quickly, and it already has the IP and was able to go to the login mask, and it already had the admin username and the password and basically filled this in. And then it was quickly verifying that it was available. So let's have a look at the test report. All right. So this is a test report. So whatever written in as a documentation, you will also see in the test report itself. Like first time seeing a Robotframework test report can be a little bit overwhelming. There's lots of information available, but we'll go into the details basically. So you can see the different tests we executed. So we checked that Grafana is ready basically, like verifying all objects created by the Helm deployment. Then we obtain the Grafana URL, and let's go a little bit into detail here. Let's make this bigger for you. And here you can see again the KubeLibrary KubeLibrary keywords. I will switch to log level trace because then we can see basically the whole response from the Kubernetes API. So it's basically responding with this JSON object. And inside here, you can see again, there is an object called status, load balancer, ingress, and then we're basically getting this IP address. And it's quite similar with the port, basically. And for the secrets, it's quite similar, but also interesting to see. So basically what we're getting back is first like a lot of encoded data, but then we can basically, that's just because of the trace log, but then we can see what we are getting back in detail from the Kubernetes API. And we are basically getting this string as a password back and this string as the admin. And then we can basically use base64 to encode it, and username is admin, and the randomly generated password is in this one. So all good, and we can then log into Grafana, which we already have seen. Yeah, so this is how you support your UI tests with some infrastructure tests before. This is basically what I wanted to show you. All right, let's switch back to the presentation.
Right, so I hope you enjoyed our demo. Now you got a taste of what KubeLibrary can do and how to take first step using it. And yeah, there are many definitions of DevOps, but I think the common goal around them is to bring just people closer together by using same tools and same processes. And definitely Kubernetes has a lot to offer. and it creates a common ground for testing, operations, and development teams, turning DevOps into DevTestOps. Thank you.
Yeah, thank you very much. So that's it, basically. Feel free to connect with us on LinkedIn, Twitter, or GitHub. Come by the project, have a look. If you see anything missing, we are always happy for new issues raised or anyone who wants to open a PR. And we are also quite active in the Robotframework community. There's a Slack available if you go to robotframework.org. And there's a Kubernetes channel if you want to discuss anything Kubernetes or KubeLibrary related. So yeah, let us know if you have any questions.